Dear viewers, welcome back to our channel Last Minute Electrical. I am Soikat Ghosh here to discuss about the subject Power Electronics EE603. In the first class, we already discussed the entire topic of diode. In this today class, we will discuss few parts of Thyristor. So in this particular video, we will discuss the introduction to the Thyristor, then the VI characteristics of it, then there are turn on method of this Thyristor and the switching on characteristics of these devices, and we discuss a special case in where we are connecting the gate when the device is in reverse mode. So let's check what is the Thyristor, means the introduction part. So from where the Thyristor name will come, this should we have to know first before the discussion about the Thyristor. So this name came from the Thyratron, another device, and transistor, another device. So the THYR name came from the Thyratron, and the ISTOR, this is come from the transistor, and both of these combine and create the name Thyristor. Okay, so why this? Because the name, the device Thyratron, the working principle of it, Thyratron, is near to similar with the Thyristor, and the construction view of Thyristor is near to similar with the transistor. So from the working principle, it near to same as the Thyratron, and from the construction principle, it is near to same as the transistor. That is why this name is Thyristor. Under this Thyristor family, there are many devices, among which one of is known as silicon control rectifier, SCR. This is the most famous member of among the Thyristor family. That is why sometimes this Thyristor family is known as SCR itself also. Okay, so let's go for the introduction second part. In here we will discuss we'll see the constructional view of a Thyristor, then the schematic view of a Thyristor, and next one is the last one is the symbolic view of a Thyristor. So this is the construction view. Basically in case of diode, what we see, there is two layers, one is P, another is A. In between there is a junction that is known as J1, and there is two terminal, anode and cathode. But in case of here, we see there is four layer. We can see there is four layer, PN, PN, and three junction, J1, J2, and J3. And terminal, how many terminal? Three terminal, anode, cathode, and gate. So what is the working of this gate? In case of diode, what we know? In case of diode, we know diode can flow the current in only one direction, that is anode to cathode. But that is uncontrolled, means when the anode is positive, cathode is negative, current will flow. No control in our hand. But in this SCR, same thing, but that is a control device, because there is a gate terminal included over here. Means what? When anode is positive, cathode is negative, then also current will not flow like diode. In here, current will only flow when gate terminal is triggered. Means anode positive, cathode negative. In case of diode, current will flow. But in case of SCR, if anode positive, cathode negative, then also current will not flow. If only gate is triggered with the same condition, means anode positive, cathode negative, then only current will flow. Means what we can say, conclude from here, conclusion is that diode can be compared with a one-way road. But in case of SCR, that will compare with a one-way road with a signal, with a road signal. Means what? Road signal is same as gate. In case of diode, one man can go always north to south, means one-way route, north to south. But in case of SCR, a man can go north to south only when the signal is green. If the signal is red, nobody can go north to south. Only signal is green, means gate is triggered, then only current will flow, means the man will go north to south. Unidirectional device. This is also a unidirectional device, and this is the symbolic view of SCR. Okay, so let's check the VI characteristics of SCR. So this is the VI characteristics of SCR. In here we can see this is the positive voltage side, this is the positive current side, this is the negative current side, and this is the negative current side, and that is the negative voltage side. Okay, So in here what we see, this is the, we know this particular part means from the 0 point to this red area up to VAB, this position is known as forward blocking condition. So let's check what is this actually. Forward blocking condition means what is this, let's check. So this is the forward blocking condition. In here what is the connection? Anode connected to positive and cathode connected to negative. So when anode is connected to positive, cathode is connected to negative, and gate is open, so forget about gate. In here what we know, this P1 connected to positive and N1 nearest polarity is minus. So when P is plus, N is minus, the junction between it should be forward bias. So that is why we are written forward. Now next one, N1 now nearest polarity is positive, P2 nearest polarity is negative. So the junction between these means J2, N positive, P negative means that is in reverse bias. In last junction, P2 nearest polarity is positive and N2 nearest polarity is negative. So that is why this junction J3 is the forward bias. So in this case, that is why current cannot flow, because the junction 2 is in reverse bias, means the dielectric strength of this junction 2 still in here, and the polarity difference between anode and cathode create a pressure on this junction, particular junction J2. They will not create any pressure on junction 1 and junction 3 because they are forward bias. Total pressure come to the junction 2. That is why current cannot flow. So that is why in here we can see voltage increases. Till now current is not increases. But there is, you may ask, why this gap then? There is very few amount of current in here flowing through this junction 2, that is known as leakage current. This particular portion, what is leakage current, we already discussed in the first video. Okay, so this is the leakage current, that is a very few milliampere. We do not take it in account. Okay, so now this is the J2. So now if we increase the polarity difference between this anode and cathode, what will be happen? Once upon a time come, this pressure of the polarity difference between anode cathode cannot resist by junction 2. So this reverse bias junction 2 will be break down after a certain amount of voltage applied between anode and cathode. That is known as forward voltage breakdown. Forward voltage breakdown. That is why it is denoted by VFB. Forward voltage breakdown. Okay, when the junction 2 is breakdown, then what will be happen? Current easily can flow because J1, J3 already in forward bias and J2 now breakdown. So current will be flow from anode to cathode. So after when the polarity difference between anode and cathode just reach the VAB, means forward breakdown voltage, at that instant this junction 2 will break down and current start flow. That is why after this, when we increase the voltage, the current will further increases. So there may be a question, why there is also contained some amount of voltage, because this is a semiconductor material. So these semiconductor materials also contain some nominal amount of resistance. When the current passing from here, there should some voltage drop, that is known as forward voltage drop, IR. This is also already discussed in the first video. So this is up to this 0.2, this VAB means red color line is known as forward blocking mode, and from this VAB to up to this point means this green color portion is known as FC, means forward conducting mode. So total, one thing you should remember, I don't say anything about IG3, IG2, IG1. I will tell for after 2-3 slide what is this. So in here what we see for this entire operation, we see that gate terminal is open. So that is why in this particular point we have written Ig equal to 0, means the gate current is 0. So this is from this slide we will discuss the forward blocking mode and forward conducting mode. So in the next slide, means this slide, we will discuss the reverse mode of operation. So in here, N1 nearest polarity is negative and P2 nearest polarity is positive. So that is why junction 2 is forward bias. In the same logic, we see the P2 nearest polarity is negative and N2 nearest polarity is positive. So P connected to negative, N connected to positive. So junction between this P2, N2 means J3 junction is in reverse bias. So in here, anode connected to negative, cathode connected to positive. When we apply this polarity, then this polarity voltage supply, then it's seen that total current will be opposed by these two junctions J1 and J3 because they are in reverse bias. So when we increase the polarity difference, so junction 1 and junction 3 oppose the flow of current. That is why when we increase the voltage, current will not flow. This much amount is already known. This is the leakage current. Okay. So once upon a time will came when this pressure between anode cathode, means the polarity applied between anode cathode cannot resist by the dielectric medium provided by J1 and J3. So they will break down. Means the dielectric strength of J1 and J3 will be breakdown by the pressure created by cathode and anode. So then current will flow through this device, and this is known as reverse conducting mode. This test will never perform because this may create the permanent damage to the SCR or Thyristor. That is why we will not perform this thing. So before closing the VI characteristics, we will just revise once that from this particular 0 point to this VAB point up to this point is known as forward blocking mode. From this particular point means VFB to this particular point is known as forward conducting mode. In here that is known as forward voltage drop. This particular area is known as leakage current, and this particular point is known as forward breakdown voltage. So let's go for the reverse mode. From this 0 point to this point, VRB means V voltage reverse breakdown voltage up to this point is known as reverse blocking mode, and from this particular point to this particular point is known as reverse conducting mode, and this is the area is known as leakage current. So this is the VI characteristics. In turn we perform this when the gate circuit is open. That is why we will not say anything about IG3, IG2 or IG1. We are saying only IG is 0 because gate circuit is open. Okay. So there are various methods to turn on a thyristor. What are those? First one is the forward voltage triggering, second one is the gate triggering, third one is the dV by dt triggering, and fourth one is the temperature triggering, and final one is the light triggering. So we will check once at a time. So let's go for the forward voltage triggering. In here, what we know already, this portion is clear in the VI characteristics. Just revise one over here, that forward voltage triggering means what? Anode is connected to positive and cathode is connected to negative, and gate is open. This is the main thing. Gate is open. In here we are not using the gate for triggering on a FCR. In here anode positive, cathode negative. That is why junction 1 forward, junction 2 reverse, junction 3 forward. So in here we will try to trigger on, means we will try to make it change to a conduction state. Till now, when junction 2 is reverse bias, no current will flow through this device. So we will try to make it on by increasing the forward voltage, means the voltage applied between anode and cathode will increase. With the increase of that, what will be happen? The pressure will increase in the dielectric strength of J2 layer. So once upon a time will come, the junction 2 dielectric layer will be break down by the polarity difference pressure created by anode and cathode. So when this is will be break down, the device goes to conduction mode. So in this way we can trigger a SCR from off state, means off state to on state, but that is not an effective solution, because in this way that also may created a permanent damage to the devices. So second one triggering method is gate triggering. This is the most finest method and effective method to trigger a SCR. Okay, so in here we will discuss the remaining part of VI characteristics, what is IG3, IG2 and IG1. So in here what we see, in here we are using the gate terminal. Okay, so look at here. In here, gate terminal is connected. Previously, whatever we seen, in that case, we seen gate terminal is open. First time we are seeing that gate terminal is closed. So what is the advantage of it? Let's look here. So anode is positive, cathode is negative. Same thing, junction 1 is forward bias, junction 3 is forward bias, and junction 2 is reverse bias, junction 3 is forward bias. Okay, so by using this anode and cathode, a pressure created over here, junction 2, the dielectric strength, we have to break this dielectric strength. Once break can be possible by creating the pressure by anode cathode with gate terminal open, but in here we destroy this dielectric strength with the help of both, means the pressure created by anode and cathode and also the pressure created by this gate. What we will do in here, suppose let's assume a figure that for creating this for destroying this dielectric strength, we have to require 100 pressure among this junction 2 layer. Okay, 100 pressure required for destroying or break down this junction 2. So let's assume the 80 pressure is given by this polarity difference between anode and cathode, then 20 will supply through gate, so terminal will open. Suppose anode cathode provide 60, then we have to provide 40 through gate. Now my question, how we provide the pressure through gate? How? Let's check. By this gate terminal, we are injecting some holes in this P2 layer. Okay, so when we injecting some extra hole in this P2 layer, then what will be happen? These hole are try to combine with this N1 electrons, so these holes create more pressure in this junction 2 dielectric layer for combined with the electron of N1 layer, so it create or it increase the pressure. So that is why if anode and cathode give a pressure, remaining pressure should be created by gate terminal. So in here, suppose the 100 pressure required for break down this J2 layer. So the red color, when the gate circuit is open, then we tell that Ig is 0, means created pressure by gate is 0. So total 100 is given by anode and cathode. Now if we apply a Ig1, this is the Ig1. If we apply this Ig1, suppose this is the 20. So 80 means this much. From this point to this point is, let's assume 80, which pressure is created by the anode and cathode, means polarity difference between anode and cathode, and this remaining 20 part is given by the Ig1, means gate terminal 1. Now look at here, suppose from this particular point to this particular point is 60, so this 60 create this. From here to here, this 60 polarity difference created by this anode and cathode. Remaining 40 is given by Ig2. So total they combine to 100. This 60 is given by the anode and cathode, and this 40 is given by the gate terminal. So total combination to goes to 100 and device will break down. In the last point is that suppose this is 40, this much pressure is created by the anode and cathode, and from this particular point to this particular point means 60, so total combination is 100. So conclusion is that by using gate terminal we can trigger the Thyristor. When if the gate current is higher, then voltage difference between anode cathode required is less. If the gate current is lower, then the voltage polarity difference between this anode cathode is higher. So this is the conclusion from the gate triggering method. So next one is dV by dt triggering. dV by dt means what? Rate of change of voltage. Rate of change of voltage with respect to time. In here, what we actually want to say? We want to say that the gate terminal is open. Assume gate terminal is open. So forget everything about gate. Now you think about the anode is positive, cathode is negative. Suppose if we across this anode and cathode, if we apply more than 800 voltage, then this junction 2 will be breakdown, means Let assume this 800 voltage is our VFV, means forward breakdown voltage is 800 volt. But before applying 800 voltage, suppose we are for a very short time of period, we are applying a voltage 0 to 600 or 700 very short time and back to 0 with a very fraction of time. Means what we are saying, suppose if we give a pulses means for a very short time very high peak value of voltage, maybe that voltage is less than the forward breakdown voltage, but also that for a very short time of period, that also may break down this junction 2. Means what, suppose there is a constant voltage 800 volt, okay, let assume there is a straight line constant 800 volt passing through here, but for a very instant time we are applying a voltage 0, somehow 60 and again back to 0, and then this much voltage, this voltage peak may destroy the junction 2 layer, means dielectric strength of junction 2 layer. May this peak value of voltage less than the forward breakdown voltage, but also it capable to break down this junction 2 layer, that is known as dV by dt, rate of change of voltage with respect to time. Okay. And next triggering method is temperature triggering. So if we increase the temperature of that particular devices, then what will be happen? Then when the temperature increases, then what will be happen? Atom vibration is increases. If atom vibration is increases, then what will be happen? The leakage current passing through the junction will be increases. If the leakage current is increases, then I square R is also increases. If I square R is increases, that also increases temperature. So by repeating this cycle to many times, then the device will be break down. So this is known as temperature triggering. Means in this way temperature increases, atom vibration more increases, leakage current more increases. In certain time will came when leakage current is break down the junction 2 and conduction will begin. Okay, so next triggering method is light triggering. So that is short form is LASER, light activated silicon control rectifier. In here the construction is little bit different. What is this? In here the gate terminal is removed, in here there is a hole is created, and where the light is we are injecting light. Generally we are injecting light of photon light, because the photon light containing huge amount of positive charges. Okay, so by applying the photon we can injecting the positive charge over the P2 layer, and the same way the junction 2 will be break down. Why we using light? Because in this particular construction we may isolate the triggering process from the main electric circuit, because by using light we are not directly not directly connected with the main electrical circuit. So this is an isolated triggering method. So this is also very effective case. Okay, so this is the the switching on characteristics of a thyristor. So previously we have seen the turn on method of thyristor. There is 5 method of turn on of a thyristor. In here we will see how the thyristor will turn on, how the thyristor will be turned on. That is come under this discussion. Okay, so in here total turn on time are subdivided into 3 area. One is delay time, another is rise time, and last one is spread time. TD, TR, TS. In here 3 waveforms are shown over here. One is VA, voltage across anode, IG means gate current, and IE means anode current. 3 are shown over here. So what do we know? Basically, suppose when a switch is off, then what will know? Total supply voltage come across the switch, and when the switch is on, then what will be happen? The voltage across the switch is goes to 0, and current across the switch goes to increase from 0 to its on state current. That the same thing happening over here. Look at here, that the very starting point, the voltage across the switch is its peak value, maximum value. When the switch is already on, goes to its final value, means near to zero value, but this is the known as forward voltage drop. So this from peak value or actual value means ideal value of supply voltage to zero value come within this time period is subdivided into three sectors: delay time, rise time, spread time. Look at current. Current is initially zero and goes to its on state current. This total change of current is subdivided into three area. Okay, so from particular this point means the peak value of the switch voltage, supply voltage, is changed from to 0.9 of VA. 0.9 of VA means, suppose let us assume the voltage across the anode is 100, so it's changed from 100 volt to 90 volt. That is known as delay time. 100 volt to 90 volt or VA to 0.9 of VA is known as delay time. In case of gate current in this time obviously increases because gate current is increases. That is why the switch is goes to off state to on state. So that is why in this time the anode the gate current is 0.9 of its final value. So this is the final value of gate current. Suppose this is the 100, so this is the 90. So gate current when 90 to 100, that is known as also delay time. And in respective of anode current, we can say from the zero value or the very initial value to 0.1 of peak value means 0.1 of IA is known as the delay time. Suppose this is the 100, this on state current is 100, then we can say 0 to 10 ampere current is known as delay time. Change of 0 to 10 ampere current is known as delay time. 90 to 100 of gate current change time period is known as delay time, and anode voltage from 100 to 90, that is known as delay time. If the on state voltage is 0 and the peak value of voltage is 100, and in here gate current final value is 100, and in case of IA means anode current, on state current is 100. This is an assumption. So better definition is from 0. Peak value of voltage to 0.9 of VA or 0.9 of IG to its final value of IG or initial value to 0.1 of anode current. That is known as delay time. Rise time is what? Rise time is 0.9 of voltage across the anode to 0.1 voltage across the anode. This time period is known as rise time. Okay, in case of current, anode current, that is what? Anode current is 0.1 anode current to 0.9 anode current is known as rise time. Suppose we are giving an example, if on state current is 100, then we can say 10 current to change to 90, this much time period is known as rise time. In here we can say if the on state voltage drop is 0 and peak value is 100, then we can say 90 volt to 10 volt, this change of time period is known as rise time. Okay, so up to this part is known as rise time, but we cannot define the rise time with respect to gate current because throughout the period of rise time the gate current is constant. That is why we cannot define the rise time with respect to gate current. Now the last part is spread time. Spread time means what? With the respect to anode voltage, we can say the voltage across the device, we can say that from 0.1 of VA to its on state voltage drop means what? Suppose on state voltage drop we are assuming very less, means 0.5 volt. Let us assume on state voltage drop is 5 volt and the initial value is 100. Then we can say this, the change of voltage from 10 to 0.5 volt, 10 to 0.5 volt, this time period is known as spread time. Okay, in case of IG we cannot say for the same reason because that is the constant for the entire time period. Okay, and the anode current, if we consider the anode current, then we can say the change from the current to 0.9 IA to it on state current, that is known as spread time. Suppose it on state current is 100, then we can say from change of current from the 90 means 0.9 into IA to its on state means 100, 90 to 100. The change of current from 90 to 100 is known as spread time. Okay, so this is the three part of turn on methods of a thyristor: delay time, rise time, spread time. So this is the delay time, entire thing is the delay time, this entire thing is the rise time, and this entire thing is the spread time. The total time period from here to here is known as turn on time. So can you assume how much time taken to change the voltage from here to here, or to current here to here? Means how much time practically taken by a device to turn on. Do you know? That is only 15 to 20 microsecond. That we'll analyze, and the researchers are subdivided in three sectors. 1, 2, 3 means the total 15 to 20 microsecond are subdivided in these three sectors by the researcher. Okay, so that time period is very less, 15 to 20 microsecond only. So now we will discuss a special case. In here, what we do that we make the device in the reverse mode. Means what? Anode is negative, cathode is positive. That is why junction 1 reverse, junction 2 forward, junction 3 reverse. In here we are connected the gate. In here gate circuit is looks open, but in here we will connect the gate. Then what will be happen to this circuit? That is a special case we will discuss over here. If the gate terminal is connected, then what will be happening? Just pause your video and think 1 or 2 minutes, then you resume this video. Okay, so what will be happen? Look at here. The happening is over here is that when the gate terminal is connected over here, what will be happen? The P1 and N1 is lightly doped. So lightly doped means what? The lightly doped means what? Lightly doped means that the doping amount over here is less. Means it requires more force to make it conductive mode. And P2N2 is highly doped. P2N2 is highly doped. P2N2 is highly doped. What does it mean? The dielectric strength of J2 layer is less compared to J1 layer, because P1 and N1 is lightly doped. Means there is number of holes and number of electrons less, so they create less pressure over here. And in case of P2, N2, they are highly doped. Means what? There is more holes, more electrons, so they create more pressure. So junction 3 will face high pressure by P2 and N2, and junction 1 dielectric strength face low pressure by P1, N1. So when gate is connected, some positive charge holes are injected to P2 layer that create more pressure on junction 1 and junction 3, but junction 3 already getting more pressure. So by applying gate, somehow pressure is increased when junction 3 and junction 1. Junction 3 is first breakdown, because junction 3 already getting more pressure compared to junction 1. That is why junction 3 is first breakdown. When the junction 3 is breakdown, this entire pressure created by anode, cathode and gate, total pressure come to J1 layer. Then J1 cannot resist this entire pressure. Then junction 1 is also breakdown. So in the reverse operation mode, if we connect the gate, sometimes all of we think that device will never turn on, but that is wrong. Device will be turned on by first breakdown the junction 3 layer and second breakdown of junction 1. Then the device will be on. So this is a special case we discuss over here. So for the this video lecture, this is the last part, and from the next video we will discuss the latching current, what is latching current, what is holding current, and turn off characteristics of SCR, rating of it, and different type of protection of thyristor. So for this video we will end over here. Thank you for watching Last Minute Electrical. Goodbye.